Hello everyone, welcome to the second session of learning SAP2000 analysis software. So our example today is on seismic design of a four-story reinforced concrete building according to the new Turkish earthquake code released in 2018. So our today's example is a very simple example, as you can tell from the floor plan. Of course, this is for demonstration purpose, so I want to be quicker in the modeling and analysis. So that's why I chose like a very simple building so that I can try to cover many things in very small time. So the material here is said to be C25, which means that the concrete we have 25 megapascals of compressive strength, and the beam sections, all of them, they are said to be of these dimensions. The slab thickness to be 14 centimeters. The location is chosen to be Seismic, so our building is assumed to be in this region. We have also another condition regarding this building, which is stating that we have a 60 Newton per meter of loading on the normal floors, which means that here we don't have no wall load on the upper story. Below also is a table containing the dimensions of all column sections. You can see that the first and the second story, they have the same section, and the third and fourth also they have the same sections. On the right also is the loading to be used in the analysis. So we have the dead load and live load that we apply on the slabs. So obviously you can see that I have like already dimensions for both columns and beams and also the slab as well. So it's because I'm working on assumption that I got these sections dimensions from the preliminary design. So I think everyone here is already familiar with how to carry out a preliminary design. So to be quick, let me go ahead and start by creating the model in SAP2000. So first thing is to check, I think you have to do is to check the units if they are correct, and then you go ahead and you choose to create a new model, which I already did, and save it. So in my case, I've already saved the model, but I'm showing you because I want to highlight again that you have to create a folder and save your model in that folder. So when you do that, you name it and then you save it, and then you start your modeling. So to start the modeling, start by editing the grids so that you can create like a map for our building that we have to follow. So to do that, I have to check quickly on the floor plan and the side view to get the information that will help me in creating the grids. So you can see that in the X direction, I will need like 3 grids, and the Y direction, I will need also 3 grids. And the Z direction also 1, 2, 3, 4, 5. And also I have to keep in mind these like bay width, like here we have 5 meter here. So after checking all this information, I think I'm confident enough that I can easily create the grids. So as you saw from the floor plan, we need 3 grids. So one is at 5, another one is at 10 meter. And in the Y, you saw that we also need 3 grids, one at 3.5, another one at 7 meter. In the Z direction also, we needed 5 grids. So one at 4, because the first row is very different than the others, and another one at 10, at 7, another one at 10, and the last one at 13, because the following rows, they all have like 3 meter each of story height. So after I create my grid, I click on OK, and then here we have our grids ready. So let me use this option to bring everything to the normal. So let me choose XZ. Actually in my design I want to have like on the right side a 3D demonstration of what I'll be doing on the left side. So I just created grids, which is the first step. The next step should be to create the material, to define the materials. So to do that, I went on define materials, as you saw, add new material. So in this case, I choose Europe because I think last time I didn't do like a realistic example, so I was using like custom material. But in this example, I want to do like to use material which are like real and are used on the job market. So the region is Europe, which we are in. The material type, of course, concrete, and the standard, the European standard. This one is, of course, this is the only option we have. And the grading it will be this one, as you saw from the building description. And then I click OK. So after clicking OK, you can see that the material is created, but I want to see and check like what are the properties of that material. So you have the weight per unit volume, which is 24.9. Normally it is 25, but I think this is okay. And you have the modulus of elasticity, the position ratio, everything is well defined, I think. Let me put this in megapascal to check, or Newton per meter square. So to be like sure that I'm using the right materials properties, so I have to go ahead and check like the TC500. I have it already open here because it contains the properties for all materials. So for the C25, you can see that this is true, but I think the modulus of elasticity is different from the one you have in the software. So let's go ahead and try to change that. So it is 30,000, not 31. So after like editing that, I think I can click on OK. So these are like default materials that the program like suggests you to use, but I think we don't need them now. I can delete them. So the next step is to create, we just create the concrete material. So we also need to have another material for the rebar, the reinforcement, because it's a different material. So you choose also here, you choose not steel, because this steel means like the structural steel, like S275, or so in our case, because we want to define the rebar, we have to choose rebar and click OK. So after creating the rebar, it's very good that we change the name to like S120 as our rebar. So I think this is the weight per unit volume is okay. The modulus of elasticity is okay. But here we have like the Fy and Fu, which may not be the same as like the one used in Turkey. So that's why you have to go ahead again and check the Turkish standard 500 to be sure that you are using the right definitions. So you can see here that like the rebar is defined to like the one which is commonly used is this one, if Fy of 420 and Fu of 550. So we take these values and insert them in SAP. So we have 420, 550, 420, and 550 for this one. Yeah. So the reason why they're like these two parts they are the same is because to be on the safe side, you don't want to estimate like the expected yield stress to be higher than the one from the minimum. So normally because we are going to do like a linear analysis, you don't need like to have this value to be different than these ones, because our breeding we stay in the elastic limit. So then I click OK. So I think I'm done with the material definition. Now I think the next step should be to create the sections. So to do that, I come here and click frame sections, and I click on add new property. I choose concrete, and all our section, because they are rectangular, I choose rectangular. So after doing that, I think the next step, let's try to rename the section. I think the first column we're going to create, let me go ahead and quickly and check. So let's start by creating the S1 columns, or the section in the first row. So we have 25 by 40, 40 by 40, 40 by 30, and 45 by 35. So normally, like as a methodology, the member dimensions that are written this way. The first part is the x dimension in the x is written first, and then dimension in y is written second. So this is what we are going to follow throughout our whole modeling. So let's create first these two. So it is column 25 by 40. Yeah. So you first write the x1 and you follow with the y1. So it's 0.25 meter in the x direction and 0.4 in the y direction. So after this step, you can come this way and you just have to choose. This has to do with the reinforcement. So I have to choose the material for the reinforcement, and I have to set the design type to be column, because we want to design the columns. So if this member was like the beam, I would have come here and choose design the beam. It's because you know that the columns and beam are subjected to different type of loading. So normally the column is supposed to carry the moment and the actual loading, whereas the beams, they are only supposed to carry only the moments. So I have to choose reinforced configuration to be rectangular, and the component bars, they are ties or stirrups. Again, here below, I have to choose reinforcement to be designed. So the difference between these two is that when you are using the design, you choose this one, and when you have done a design, or you are doing an analysis on an existing building, you can choose this one, and you have to edit these two sections according to what you have. And when you choose this one, the program will just run itself and tell you if the number of bars you inserted in these sections, if they are satisfactory or not. But when you choose this option, you don't need to edit these two sections here. The program will just do the analysis and design, and give you the amount of confinement bars and longitudinal numbers that you need. So please make sure that you are able to differentiate between these two. This is for checking. Let's say I just did a design and I got some values, like the reinforcement bars, how many I have, and everything. I can come again and insert those values here, the spacing, everything, and I click on check. So the program will check, and at the end of the checking, it will tell me if the values I inserted, they are satisfactory. But in our case, you don't know anything. You don't have any idea on how many reinforcement bar we need or not. So it is very advisable that you choose to be designed and click OK. And also there is another new rule that came in the new Turkish earthquake code. which which states that you have to use like cracked version or cracked properties of concrete sections. So which means that you have to modify the stiffness of or the rigidity of your concrete sections, because we know that concrete is very performs very poor in like in tensile stresses. So if there are tension applied on concrete, it cracks, and that cracking happens immediately after you are done with the construction of the building. So the code suggests that you should account for that cracking uh, right in the analysis. So this is a new rule, and of course it makes sense because you know that, like for example, the beams in their, let me try to, so the beams, you know that normally, let's say this is a beam, so we know that this the in the middle, in the mid span, it's working in tension. So which means that in the mid span we have like cracks already developing after the construction. So this is an implication that you can't just use like the whole properties, like the whole stiffness of the beam section. You can't assume it to be like 100% like intact. So there will be some damages. That's why like the code suggests you to use some modification, like or some factors to multiply with the stiffness so that you account for that decrease in the section capacity. So that's what you we are going to see. Like let me clean this quickly. So let me go ahead and check for the beams, like how much is supposed to be, how much is the factor. So for the beams, I think I have ready table here. Yeah. So actually what you are seeing here, yeah, there are some like, kind like of tables and everything like that we'll be using in this model that I took from the Turkish earthquake code. What we have here is this table 4.2. It's giving those factors. So for the beams and columns, Chechevikirish and Chechevikolon, you can see that you have to decrease the beam stiffness by 35%, and for the column 70. So let's do that. So for the beam is 0.35. Oh, sorry. Now we are working on the column. So the column is 0.7 and 0.7 here. And I click OK. So I just set the modifiers. Okay, I click OK. So we are done with the first section. Now I can do add copy and create the second section, I think, which I remember is to be 40 by 40. So be quickly. So let me, you can see all the property, because I said add copy, I have all the property like applied already. I don't have to edit again. So 40 by 40 for the column, for this column, I click OK. I check again, I see, let me create this one, 40 by 30 and 45. Add copy, C40 by 30. So this is we change and I click OK. Add copy, I think this one, 45 by 45. I edit these parts. Sorry. Okay. So let me check the upper stories. We have 25 by 35 and 30 by 30. I think these are the new ones, only the new ones. 25 by 35, 25 by 35. Okay. Hard copy C30 by 30. Okay. So I have my all column section ready. Now I can go ahead and create the beam. Hard copy beam is 25 by 50, if I remember well. So the depth of the beam is 50, 0.5, and 0.25 for the width. So remember that there are some things I have to change here because now I'm working on the beam, not the columns. So for the beam, I have to change the design tab. I have to consider that it is the beam we are designing, and I click OK. And also I change the modifiers. We saw that for the beams, they should be reduced to 0.35. Okay. I am done with like section creation. I can go ahead and also define the slabs. So to do that, I went there and I click add new. Let's call this one S14. I have to change it to be here to be 0.14 and here also 0.14. So I choose the type to be shell thin. You also have other definitions like shell thick, plate thin, and membrane. So the difference between this type is that normally for the shell thin is for slab, shell thick is for the foundation, and the membrane also sometimes is the membrane is for is normally used. It can be also used for slab, but when you use membrane, it means that the loading on the slab will be automatically like transmitted to the nearby beams immediately. But you can't read any moment on the beams when you use this one. The shell thin one is used when you want to design also the slab. So in the shell thin, as we see later, we have to divide like the slabs into parts. I explain more on that when we come to that part. So I just define the thickness in the bending, everything. I choose the material. Now let's try to set the modifiers. So and let's check for the modifiers in the table here. So for the slabs, they are saying is 0.25, 0.25, and when we come to the shear, it is 1. So let's do that. So 0.25 here, 0.25, 0.25, 0.25, 0.25, 0.25. Click OK. Okay. Okay. So now we created all the things regarding the sections, I think now it's time to start the modeling. So as you can see on the left side, I have the XZ plane opened, and on the right the 3D one. So we see that we have an indication on showing on which plane I am on. Like if I move, like I use these directions, you can see that I'm going to different XZ plane. So I can use that. I can do that also in the Y direction as well. So currently we are at the bottom. So when I do up, it goes on the first row, second, third, and the fourth. So that will be very useful in the modeling. So let's come again back here. So, and try to do the modeling. So here, let's check like first what we have for modeling. The first and the second stories, because they are similar in terms of like members, they will be designed first and then we follow with the third and the fourth one. So to do that, you have to take into account the floor plan. So as you can see that in the first corner you have S1, S2 and S3 of columns. So S1 is 25 by 35, S2 is 40 by 40 and S3 is 30 by 30. So before starting drawing, let me do like a final check to see if I did the right uh, definition of the section. 25 by 35, okay. 25 by 40, okay. 30 by 30, okay. 40 by 30, okay. 40 by 40, okay, okay also. 45 by 45, okay. So as you saw here, the first like grid, we have three columns, S1, S2, S3, which have dimension 25 by, I just checked. So here is 25 by 30, here is 40 by 40, and here is 30 by 30, if I'm not wrong. Yeah, which is correct. So I go ahead and click on draw frame or cable. I choose the dimension I saw here. The first one is 25 by 35. No, sorry. This is for the third and fourth row. So I should check for the first and second. So the first and second floor we have 25 by 40, 40 by 40, and 40 by 30 for the S1, S2, and S3. Right? Let me go ahead and do that. We have S25 by 40, so which goes like this. This is the first column, and the second one is 40. The first point to be this, and the second point to be this. So the last one is 40 by 30. Come here and I choose the section and I draw it. You can see that as I draw on this side, I can see the 3D preview of what I'm doing on the left side. So this is very helpful. Maybe you can do it very better here by setting the view to be extrude so that we can see like the exact 3D view of this thing. 1 second. Okay. So now you can see like exactly what I'm doing here is being displayed in this part. So the next thing here, I'm going to copy these or to replicate them to the other side, to the last grid, because you can see here like S1, S2, and 3 is the same for the first grid and the third one, S1, S2, and 3. So I don't need to go ahead and draw them one by one again, so I can replicate them by using the command. So to do that, I can either go here and do edit and click on replicate, or I can use this shortcut, Control R. So I just activated the command. So from here we are going to replicate them in the y direction, right? Because that's where the other columns they are situated. So y direction is 3.5. 3.5 is after 7 meters from the initial column. So it is at 7 meters, and I want to replicate them only one time. So that's why I put 1 here and I click apply. You can see that the command is successful So I can go ahead and create the columns in the middle. So to do that, as you can see, I am still on the first plane XZ. So I click on move up. Now I am in the middle, as you can see from the right. So let's go ahead and check on the second grid what we have. We have S2, S4, and S2 again. So we have S2 40 by 40, and then we have 40 by 45 in the middle. Let's do that immediately. We have S2 40 by 40 here on the sides. And we have, I check again, 40 by 40 in the middle. Now when I'm done, I can click and you can see that I have my columns ready. So now we are done with the first row. So as I told you, like, I just need to first model the first flow and move it up or replicate it to the second floor, because we saw that the first and the second floor, they have the same dimensions, so, and the same section. So there is no need to model the first row alone and go ahead again and model the second floor one by one. So I can combine, I can model for one floor and then replicate to the second floor. So now you are done with the columns. Maybe at this stage we can assign the support, or the support by choosing like the fixed base or everything, but we can do that also later. So the next step should be to model the beams. So to model the beams, I have to come to the XY plane. Now you can see that I am at the base, so I need to use this arrow to come to the top, to the first row at the top. So now here I am at the top. I have to come here and choose the beam section. As I told you, to do the modeling for the beam, I use this methodology from left to right. Then I do it like this. 1 second, this one, and then drop the beam for the other side. Okay, so now I am done with the beams. I can go ahead and click, yeah, so let's come here and refresh. Okay, now you can see that the first row, we are done with the beams and columns. I think we can also go ahead and create the slabs. To do that, we come and use this tool for rectangular area. So I choose the section is S14, and then I draw them like this, and then like this. So I draw all the slabs. Okay, so since we are done, I can come over here also and try to update the view so that we can see how the slabs they have been formed. So now we are done with the modeling the first floor. All the parts has been already modeled. So now I can go ahead maybe and assign the loads on the first floor. So when I finish assigning the loads, I can copy this one and move it to the second floor. Don't have to assign the loads on the first floor and then again do it on the second one. So to do that, I select the areas and I go to define. But before I assign the loads, I think I need to create first, to define the loads, what kind of loads I'm going to use by using the load pattern property. So the date is already defined. Let me go ahead and define also for live load. I call it live, and the self weight multiplier is 0 for live. I click add new, and then we do like for the earthquake, because we are going to do a seismic design, so we need to add the earthquake. So I have to click the type to be quake, autolateral load pattern. So I have to come and choose the Turkish one, auto seismic loads from Turkish code. So which is this 218, and I click on add. So normally, like usually, like in the past, these 2018 autolateral road pattern was not included. So before that, we needed to the loads were being calculated by hand and then assigned in the program. But in our case, because this code is included in the SAP2000, we just choose it and it will do the seismic load calculation by itself. So when you create this one, we have to come inside here and do modify the load and modify the load pattern. So currently, I'm not going to go and try to explain this. I will do it later before we do the design. I just come here to just show you that you have to be sure that you choose the right direction. So this is the earthquake in the X direction. So make sure that you choose this one, and then you can do again earthquake in the Y direction, and you do like add new property, and you come here and modify and you put it into Y, because this is the earthquake that will be applied in the Y direction of the building, and you click OK. So after this part, I think I can assign my load. We talk about the earthquake, like what kind of method we are going to use to design after, but then let's first do the assignment for the loading. So to do that, I just selected the areas and I come here, assign area loads uniform to shell. So first I'm going to assign the dead load, which you can look from here. The dead load here is supposed to be like in the normal flows. So the first flow is the normal flow. It should be 1.5 kN per meter square. And the live one is 2 kN per meter square. So I come here, I put 1.5 for the dead load, and I click on apply. So if you want to select again this slab for the assignment for the live load, you come here and you do like use this tool, previous selection, to select again the areas so you can apply the live load. So I choose live load, the direction is gravity, so downwards. I click on apply and then the load is applied. You can check again by doing this. Come on loads, you see what kind of loads they are applied on the. You can make sure that you apply them on the slabs. Yeah. So now that we are done with modeling the first row, everything, and the assignment of loads, I can come up here and copy this row and replicate it to the second floor. So to do that, I just set like this view so that I can see all the members. I can select them. So I do this selection like this, and I do the replicate, Control R. So because I want to move it like in the Z direction, I have to set this to 0, and Z direction I want to move it at 3, because you know that the second story is 3 meters, so I have to write a DZ to be 3 meter, and the number of replication, I want to replicate it only one time. So I do apply, and then you can see that the flow is replicated here. But we have one problem, which is this one. So the first flow had like a 4 meter of story height, and the second one has 3 meter. So the problem here is I just copied this row and it has 4 meter of story height. So which means that 1 second, let me try to annotate. So which means that when I did the copy, this story came, and because the columns, they are 4 meter long, so they reached this level, which is not correct. They should be like stop to up this level, right? So I will have to move these like edges of the columns and move them up until here to be exactly like 3 meters. So to do that, let me show you immediately how we can solve that issue. I come in SAP2000. I don't know, like I can show it to you here also because they are 4 meter long. Don't know if you can tell from here, but you can see that the columns, you have like new joint here which were not there. They are like at this section. So I will have to move them. To do that, I need to create like a new grid. That's how in SAP2000 it is done, because if I cannot create a new grid at the end of these columns here, I will not be able to move them up. So what I do is I do and modify. I come in the Z direction. I create add. So you can see that because they are 1 meter, like they have 1 meter of difference in terms of like flow height. So it means that these columns, they are at 3 meter from here, right? Because this is 4, so 1 meter here below that, which is the excess. So it should be, the grid should be at 3. So I do click 3, I put 3 and I click OK. And then you can see that our grid is created. So at the place like where the columns end, I have a grid there. So it means that I can use the navigation here in this part. Let's do XY. I can do the navigation and come to this stage where the columns are ending. So if I can do that, I can select those joints here and move them up here, which I'm going to do. Edit, move. So I want to move them 1 meter above. So I have to do 1 meter and I click apply. Don't know if you saw when I did that, but the joint, they are no longer there. You can see that I can't select any joint. It's because they moved. Now we have like the story height is 3. You don't have the problem. So now that I am done with the first and second row, I can quickly go ahead and create also the third and fourth row.